He's a seasoned machine learning engineer and is currently serving as CTO of Vertify GmbH, as we learned yesterday, where he's spearheading the development of the class 2A, hopefully I spelled it correctly, medical device for integrating eye movements on the smartphone. At Vertify, design and co-create the in-house synthetic data generator as well as the associated machine learning models. Prior to this, Christoph worked as a senior data scientist at IMC, where he implemented a variety of natural language processing and computer vision projects in the medical and the insurance sector. Beyond his industry work, Christoph has made significant contributions to the open source community. He has developed and contributed to several widely used packages in machine learning, data visualization, image processing, image augmentation, including Augmented and Clinical Plus. I think that should be enough. The stage is yours.
So the past 4 years I've obsessed about one particular subject, which is analyzing human faces for safety critical applications. So when you hear human faces, analyzing human faces, you get a big broader webcam, right? Violating your privacy. But there is a lot of benign good reasons to analyze faces. So eye tracking is one of them. There's lots of reasons to do eye tracking. For example, you want to see where a driver is looking in the car, on the road, or on the phone, or on the mirrors, or something that we're doing, you want to monitor the eye movement patterns themselves for medical reasons, or even entertainment purposes, or user interfaces, and so on. Another reason why you want to analyze faces is facial structure. Face ID, we all know this, identification or the movement of the facial structure, such as are the eyes closed or they open, is the person squinting, what is the emotional state, what is going on in the scene of the face. And I picked the third one. You can pick an arbitrary number of examples. I picked 3 because it looks nice on the slide. And the last one is a bit more of a playful one, which is visual try-ons, such as we all know this kind of effects that smoothing your skin on pictures, or visual makeup, trying on glasses in augmented reality, or the use case I chose, which is reliving the good old times before you knew what it means to develop facial analysis for safety critical applications. So let's talk about eye tracking for a second. So this is kind of what an iPhone would see when it does eye tracking with our software. And the point of this is there is a lot going on here. The machine needs to see where is the face, what is the face doing, how is the head moving, which parts of the head are usually important for estimating the head pose, and then finding the eyes, analyzing the eyes, all to get some curves out, combining all the information to understand where the eyes oriented relative to the head. So there's a lot going on. We find the face, okay, there it is. We analyze the head pose. I think it's fair to say that there's enough information there to analyze the head pose. We analyze the right eye, okay, and then we analyze the left eye. You might get a little suspicious here, like, analyze what exactly? There is no eye, right? And it seems obvious now, but you need to think about these kind of things that design the systems. It's like, how does the system know which part goes where and when it advances and so on? Because there might not be the super simple answer to saying, oh, the head pose is greater than this, I don't analyze. So different parts of this system need different kinds of data. Because what you really need in your system is, first of all, a bunch of post-processing, normal code, so not everything is machine learning. You need to analyze the face detections, you need to keep track over time and so on. But what I think is important here is this filter stage. And the filter stage I would call domain gating, which is essentially about that the system, the point is you need to progress in realism, but realism alone is not the answer. Most of them face the camera or have slight rotations, and pretty much all of them look at the camera. And it's hard to train eye gaze or eye tracking if all your pictures look at the camera, right? So you need variety that you might not have aside from other diversity issues. Okay, what about this? What if we generate lots of images of eyes, and let's assume they're super realistic, and I point them in all directions, and I have perfect labels for them, and I generate infinite. If I generate infinite, I see all the cases, I let it train for a long time, because everyone has a lot of money for compute lying around, and then I solve my problem, right? Well, one would think that, and one thing that we encounter in our use case is that suddenly we get something like this. The model for the first time sees something that is white, that is not part of the eye. And that's just confusing for the model. How should it know these things? Synthetic data really helps. Of course, you need real data too. These are examples from the kind of data that we synthesize. We spend a lot of time on it there. And the difference to other ones is there are 3D renders with a bit of over.
All this eye analyzing. There you go.
Thank you, Christoph. I really like your presentation. And the first question is, what is the applications for the eye tracking system like? Are there some use cases already?
So we come from the medical industry, and our use case is business assessment. I didn't go into it because it's not that relevant for here. But since the medical industry is medical products are very regulated, we had to think about problems that we didn't think about before. And we realized that eye tracking in practice is most of the time this kind of, it should work reasonably well most of the time. And so we had to figure out that, okay, if you want to get it working on the long tail, you have to do all these kinds of things. And then we think, okay, there are other domains too that have safety issues like vibrating cameras, moving cameras and this kind of things.
And those faces look really terrifying.
Yes, and that's also a point, by the way. I didn't want to bring it, but if you want to create a system that works in real data, you also want to create faces that are not pretty. You want to create, especially in healthcare, you want to create faces that have skin conditions. You want to create faces that might not even make that much sense often, because often an old person might not have peak hair and things like this. Culturally speaking, but you want it in there. So if you kind of base your sensitivity is based on looking at a face and saying, oh yeah, I can imagine a photo being like this.
Do you use this kind of information for looking for eye diseases like glaucoma or keratoconus?
Not at the moment. We simulate a lot of kind of issues. We simulate cloudy cornea. We simulate very red eyes, yellow eyes, just that it works with it to get tolerance. But the main thing we're looking for is movement patterns. For example, direction changing nystagmus, or this kind of information that we're looking for.
I think we're done. Please, another round of applause.